Hello, so welcome to a new video. Today we're going to do valid parentheses, which is number 20 in LeetCode, and it is an easy problem. We're going to go through this using our solution process. So my solution process, I just like to read over the statement, get the input and output from it. And once I know the input and output, I can go ahead and do some examples to showcase my understanding. And then all we can do is we can go through some approaches, then make a plan for the approach that we think is most optimal or easier to do, depending on what we want to do or what I want to do. And then implement our approach and plan and then review it, right? So let's do that. I'm kind of tired, so might be low volume and talking slower than usual, I think. And I might miss some syntax because I'm tired. Alright, so first off, just read the problem itself. Alright, so given a string S containing just the characters, whatever I don't know what those names are, determine if the input string is valid. Okay. Okay. So first off, I'm just gonna stop there. So our input is a string containing these characters, I guess. Then for our output, let's just continue reading. Determine if the input string is valid, so I'm guessing true or false. So bool, and then if it's true, I mean it's only true. It's only true if it's valid, okay? And false if it's invalid, right? But we need some more information about this problem, correct? Right? So input string, so if it's valid, means this. So if it's valid, then that means open brackets must be closed by the same type of bracket. So open brackets must be closed by same closing bracket. And then what else does it mean? Open brackets must be closed in the correct order. So must be closed in the correct order. Okay. Every closed bracket has a corresponding open bracket of same type. Okay, cool. We know that. So we know the input's going to be a string containing those brackets, and then the output's going to be a bool to determine if it is valid or invalid, I should say. And then we know that the string is valid if the brackets are closed in correct order, and the open bracket must be closed by the same closing bracket, right? So now that we know that, let's go over some examples to showcase that we do actually understand the problem. So let's say our input is like what, it's like this. Very simple. We can say that it is true because it is closed in the correct order and they're closed by the same brackets, right? So it's true. But let's go spice it up a little bit. Let's see, our input is kind of like that, but we have it more in the sandwich, right? So we have square, circle, and then curly. I don't know if that, I think that's just regular bracket, right? It's like a regular parentheses. Okay, so in this case, let's go through it. Right, so the square is closed right here, so that's true still. And then this parentheses is closed right here, which is good. And then this curly is closed here, which is good. Okay, so what that means is that it is true that it is valid because they're closed by the same closing bracket and they're closed in the correct order, right? It just looks correct, you know. So we're gonna output true. But let's make a false example, right? I'm tired of being right all the time. So what if it's like this, where we have it like this square, then I guess like that, but we have it like this as well, I think, right? So is this true? Is this valid? Well, let's go through it with the notes that we have, right? So again, open brackets must be closed by the same closing bracket, okay? Well, we do. It is closed in order technically, if we look at it, because there's no opening bracket, but it must be closed in the correct order, which is false in this case, because here we have a opening square bracket, but then suddenly we have a closing parentheses, right? So that means that we kind of close the parentheses like already when we already have a closed bracket when we have an opening bracket, but hasn't been closed yet, right? Until this guy popped up, I guess. And there's no like opening bracket for that one, so that is not valid. Um, well, I guess it doesn't really say that, right? One thing I would like to note, or like a question I would like to ask, is if this is valid, right? So, so question is a solo closing bracket valid because it's a close bracket, and then in this case, since I've seen some examples already, it would say no. So this is not this is false that it's not valid, right? Um, so yeah, but let's go through another false example. By the way, this means that 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 if closing bracket but no opening, then false, right? So like in general, that means that it's good like that. There you go. Valid means valid case. All right, just write it like that. And so for example, that's also false. We're gonna have the same kind of deal here. Have a square bracket, but then we have parentheses like that, right? So just by looking at it, it is false, but let's just go through like why it's false, right? So here's square bracket, but then we have an opening bracket. So like, but like if we look at this is okay, right? Because if we go through this example, it's kind of the exact same thing. But if we go through it, then we see this square bracket, and that's like kind of weird because um technically, w- since we're doing it in order, like last in first out stack, um we're looking at this parentheses, we're looking at this open parentheses, and we want to find a closing parentheses, but we don't find it. We find a square bracket. And so that's not in order because we're looking for a opening. We're looking for a closing parentheses right now because we're trying to follow the order. So since this is not in order, what they do close like somehow, but it's not in order, right? Um, it's false because it doesn't satisfy this condition, right? So it doesn't satisfy that condition of being valid. So yeah. So I feel like we've gone through a lot of good cases. Oh yeah, we should do like a what's like empty. Right, so what if we're given like an empty string? So our input's like empty. I'm pretty sure it'll be valid still because there's no parentheses, so that'll be true, right? So opening or closing, I think that'll be fine. But I think that'll be like a good question to ask too. Um, will we accept empty strings as inputs? And they'll be like yes or something. But yeah. Okay, so now we've gone through through some examples. Let's go through some approaches that we can do to solve this problem. So I'm gonna match some approaches. So let me think. Um, what I kind of want to do by looking at this is we can do like some for loops, I guess, or like maybe a while loop, for loop to kind of just iterate through the string. Um, like we can also have like um pointers to the character in string to like maybe like do something about that. Like maybe we can start in the middle. So if you follow this example, I don't think that would work, but it'd be kind of hard to do. That's like a kind of like a brute force solution that's like just thought of in my head. But we can do something more optimal, right? To put optimal, we can use like a hash map, and this can like store um this can store key value pairs of closing and opening, right? Okay. We can hard code that basically. And then with that, we can also use what else can we use? And we can also use a stack. So I just mentioned it, right? My brain's lagging because I'm like kind of tired. So the in the example, I kind of use it like a stack. How like we're looking last and first out. This was the last opening to be in the stack. So we're looking for we're looking for that stacks. I mean we're looking for that um closing parentheses that matches with this last and first out parentheses that we just had. Doesn't make sense. But yeah, so last and first out. Um, we can look at opening. Yeah. So we can put new openings on top. We can push new openings on top, right? So that's what we can do. Um, so I feel like this is an optimal solution. Like you're just using a hash map and to like identify the pairs of closing and opening parentheses, and then we can use a stack to simplify the iteration process and like finding if they do match or not match, like if it's valid or invalid, right? So now that we've found the optimal solution that we're going to go for, let's go ahead and plan this approach with some pseudocode. So plan. Um, all right. So the first thing I want to do in my plan is to obviously get user input, and I can say that by saying user input is equal to input. And then what I want to do is I want to I want to hard code um, mappings of of parentheses with hash map. And then once I got that, I want to create an empty list and a stack. Okay. And then what I can do now is I want to iterate through the list and check if yeah, I want to iterate through the list, right? No, iterate through the string. Iterate through the string at each character. And then I want to say, so if character is not a isn't an opening, so if it's not an opening, so oh wait, so if it is an opening, so if character is an opening, then I want to um basically say I want to add it to stack. So add to stack. I can do that by saying yeah, I'm gonna say add to stack. Add to stack. I can say that by doing this basically. Um stack dot append character. And if character is a closing, I want to check if they're in order, right? So in order to see if they're in order in a stack, if it's a closing parentheses that we're looking at, So if it is true in this example, right? So if it was true, then in this example, we have an opening bracket. So that means that this is on top of the stack. And so when we find like mm, uh, a parentheses that is not an opening, we have to check if if this pairing, if this opening bracket, if this closing bracket's opening bracket is on top of the stack because we want it in order, correct? And we want to see if they are the same closing bracket, right? So if carriers are closing, then we can say um, we want to check if it's same and is in order. So we can say how am I going to say this? So if stack is not empty and stack and the index value at the top of the stack is equal to the pairing, where in our hash map, um, yeah, it acts as the key of character. And if that pair is literally the same opening bracket, then that means that it's valid. So we can just keep on going. And we can do that by just saying stack.pop, right? And then so if same and is in order, then pop from stack. And then what else can I do? So yeah, so if it's not the same, if it's not the same at all, um, you can just return false. Okay, right? So it kind of makes sense, right? So we kind of satisfied if it's opening, then we just add it to the stack. We just keep on adding it to the stack, and if it's closing, we gotta check if it's in order and they're the same, right? So once we're out of this iteration, we can just say like, okay, so if the stack is empty, the stack is empty because in this case, right, we would pop everything. So we would find this open bracket, put in stack, and pop it once we found its closing. Then add to stack, pop, found closing, add and push, then pop because we found a closing, right? So that means that if the stack is empty, then return true. I think that's it. So if stack is empty, return true. Yeah, I think that's it. Am I missing something? I feel like this is fine. I feel like this is fine. So what I'm gonna do is I'm going to say that okay, this code is good. Now I'm just implement it, right? Let's go implement our plan. So let's go create a main function first. And pass it for now. Then I'm gonna write in the code. Then I'm going to create a function that actually solves the problem. I'm gonna name it is valid question mark with the arguments of the input that we're given. So string. And pass it for now. And then I'm gonna follow my plan step by step. So the first part of my plan is your input. So is your input is equal to input. And then what I'm going to do is I'm going to call is valid, the argument of user input. And I know this function is valid is going to return a boolean. So I'm just going to now it's return value, either true or false. And now we can go ahead with our plan. So second step is to create a hard code our hash map and then to create an empty list as a stack. So I'm going to say stack is equal to an empty list. And then I'm going to hard code our hash map. So the closings are going to be the closing brackets are going to be the key, the opening is going to be the value. So dictionary, and then I'm going to say that the closing here, so I'm going to start with this one. The pair is going to be opening. Yeah, it kind of does that. It's kind of annoying. And then for this one, I'm going to use square brackets, and then I'm going to make its pair the, oops, I'm going to make its pair the opening. Then I'm going to continue on. I think it's more readable if I do it like this. Oh no, that's not readable, but whatever. I'm just going to put it like that, you know. I think it's more readable if I do it like this. Okay, that's fine. And then I need to do the curly, so clothing curly, and then the pair for that. I mean the values will be the opening. It's correct. Okay. And so now what I can do is I can just iterate. So I can say for character, so for character n, oops, what? For character in the string that we're given, I want to iterate through it, and I want to check if it's an opening. So if I can see if it's not opening by saying like, okay, so if character not in the it's not in the hash map, so the hash map is all just closing, right? So if character's not in the hash map, then that means that it must be a it must be a yeah, it must be an opening one. But some thoughts about that are that like what if like the user input is like something else, right? Right. So that's kind of something to think of, but whatever. I'm gonna ignore that. I'll come back to it later if it actually is a problem later on. But I would ask the interviewer if that's a problem. And if it was, I would do like, okay, so I'll do the opposite. Oh, let's do it right now. So I'm gonna say like if character in hash map. Alright, so if it is in the hash map, then I'm going to do all this stuff. So I'm gonna check if it's the same. So how do I check if it's the same and is in order? Well, if stack is not empty and the top of the stack is -1 is equal to the key, I mean is equal to the value at the key of character. So if they're the same and in order, then that means that we can just pop it from the stack. Right. Else, then we just return false. And then else, um, we can just say we can else meaning that it's an opening bracket. We can just say we're going to append it to we're going to push it onto the stack. So stack out append because there's no push function in Python. I'm going to append character. Okay. And then once we're out of that, um, then if the stack is empty, that means that we kind of solve the problem, right? So if not stack, well, if stack, um, if length of stack is equal to 0, that means it's empty. Oh, I can just say return the length stack is equal to 0. I can just say that, right? Like that makes sense. So it's code. It sounds right. So what I can do is I can just let's just get some uh, test cases going on. So correct one was this one. That's true. Okay. And then our other test cases were, oh, let me do this one first. True. Okay. What about this one? False. I'm pretty sure it's false because these are not the same. I mean, oh yeah, this closing bracket is not the same as this opening bracket, like in terms of type. Let's do this tricky one. False. Okay. What about an empty? False. Okay. I think that doesn't matter. Wait. Oh yeah, it's a else. Yeah, I think that's fine. Um, I think that's fine. One thing I can say is that like, hmm, yeah, I don't know. Yeah, I think that's fine. That's what I'm looking at right now. So let's just skip that, and maybe I'll solve that later in an interview problem, an actual interview, or maybe like a test problem. But either way, it's whatever. That test case I just did where it's like it's empty. Like, what would it do? Turn true or false? But I think we went over kind of like all the test cases that we're going through, and I think that's okay. So the runtime for wait, actually, let me just put this in the code to see what I'm missing. If I'm missing anything. Okay, so it gets accepted. Um, that's pretty good. Pretty good solution. I kind of like that solution. That was kind of fun. So we use a stack and hash map, and those are some data structures that we've learned recently, and some that I revisited and studied. Um, yeah, because a fun fact, I failed my Uber interview. It was the final round too. I failed my Uber interview final round. Uber internship, not the whole time. I failed my Uber internship position final interview because I didn't know what hash map was. But I knew what it was, but like I didn't know what it was in Python because like I've been creating hash maps and like stacks and queues in binary trees using C++, but I haven't dealt with it in Python, so I didn't know how to code it, right? But yeah, it's whatever. It's fine. We learn from our mistakes, and if you just keep living life, winning, then what are you actually learning, right? Um, yeah. Even the smartest people make mistakes, and yeah. And if someone doesn't, and if someone wins all the time, then they're probably cheating. Yeah. So yeah. To review, this is in time complexity. We're going through all the characters in the string, so that's O of n. So if there's n characters in the string, then we're going through n characters iteratively. And then for our space, we're using a hash map, which is O of n because there is n types of apprentices in the hash map and in our input. And then for our stack is also O of n because yeah, for every opening bracket that there is, we're going to put that in there, right, from the string into the stack. All right, so basically everything is linear. So O of n, time and space. So yeah, hopefully this problem was kind of helpful to go over.